Hey everyone, we're just going to get started now. Welcome to the Term 1 Masterclass. So just before we start, I'm just going to go through like the agenda of what we're going to go through today. So today we're going to go over like CAS skills, and we're going to talk about the things that your teachers don't show you. We're also going to be talking about the secrets to how VCE examiners mark your exams and really like how the marks are broken down in each question. We're going to go through complex exam type and SAC questions that are not in your textbooks. And they're going to be mainly from the first couple of chapters from your book. So functions and relations, polynomials and transformations. So you're going to get a really good understanding about those chapters. So before we start, I'm just going to introduce ourselves. So I'm Hashan. This is Adrian. We've been tutoring for a really long time. So ever since we graduated high school, we've been tutoring. And right now we study mechatronics engineering at Monash University. So mechatronics engineering is just like robotics and artificial intelligence. And we're also teachers at Monash University. So what that means is if you guys get into engineering at Monash, there's a really good chance or high chance that one of us or both of us are actually going to be teaching you next year.
Yeah. If you let us help you get in. If you're with us, then you definitely get in. If not, then it's 50-50, I guess.
Yeah. So next year we'll probably be teaching if you study at Monash University engineering. So do you want to talk a bit about why we started Mind Learning?
Yeah, cool. Yeah. So before, I'm Adrian. As you can see from the pictures, I'm the good tutor. The meh tutor is next to me.
I didn't even know you had that.
Yeah, secrets. So as Heshan mentioned before, we have been tutoring for 4+ years now. I've actually been tutoring before I finished high school, like in year 12, just, people who are in primary school and high school. And we've been tutoring, for ourselves and for other companies. And we kind of wanted to start Mind Learning last year to kind of take our own direction with tutoring. So by being students in VCE, by being students in university, and by tutoring kids by tutoring VCE students and Monash engineering students, we kind of have a wide understanding about how people learn and how people effectively learn.
Especially online.
Exactly. Yeah. Especially in the last couple of years, everything's been online, and obviously the seminars online. So we have a really good understanding about how to teach online through tutoring and through teaching at Monash University. And we kind of just wanted to take our own direction. Whereas when we're working with other companies and as private tutors, we kind of didn't have a set direction and a set, I guess, framework for tutoring. And we wanted to kind of implement that. And that's what Mind Learnings are all about.
Yeah, pretty much we just wanted to give the best tutoring and the best resources to any student in year 12. So they know where to go if they want to get the best tutoring and the best resources.
Yeah. Cool. Yeah.
I guess we'll get started.
Yeah. But yeah, it's lovely to see you all here today. Thank you. Thank you for coming as well. Hopefully you get a bit out of it. And cool. Let's get started. I guess, we'll get started. Before I do that, where's the pen?
Oh,
Before we get started, I'll just let you know that this masterclass is obviously, just like we wanted to give it gratis. And if you like the masterclass and if you like all of our online content, then feel free to ask any questions, and we'll talk about how to continue with us later in the seminar. Cool. I'll start the questions now. Let me just share my screen. Yeah.
Did you write?
Cool. So these questions essentially are questions that we made, and we specifically designed them to cover a wide range of concepts. And the actual concepts that are covered in these questions are more on the complex side. So then things that you might not see in your textbook, but there are definitely things that can come up on exams. And these styles of questions have come up on past exams and past SACs before. Is it all good with the screen share?
Yeah.
Cool. So let's get started. If you guys want a copy of this, it would have been sent to your email with like the ticket and the confirmation. So hopefully you guys have tried it before. If not, that's all good. You could just follow with us right now. So let's get started with this question. So question 1 is 8 marks, and we have f of x is equal to 1 over kx plus 1, where k is an element of all real numbers. So we can see in this question that we should be able to recognize this function as a hyperbola. Okay. The only unique thing about the hyperbola is that it's not a set equation. It actually has a parameter k. So k is the coefficient of x. So that would change the function in some sort of way. So whether it's a large number, small number, a negative number, that would change the graph in one way or another. That's all we have to know about this question. Just kind of think of it as like a constant for now. And I guess whenever having parametric equations or having an equation with a parameter or a variable like k, we kind of treat it the same as if it was a number. But obviously it's not, but treat it the same way. It can cause a lot of confusion, but yeah. So you can see in the next question, part A, solve f of x is equal to x for x in terms of k. So what we'll essentially do is just solve the equation like normal, as if we were given a set function. So in this case, we just write 1 over kx plus 1 is equal to x, and we just rearrange and solve for x. So in this case, the best thing to do is just to cross multiply that denominator to the other side. So it'll be 1 is equal to kx squared plus x. Then we could see that this is a quadratic equation. We just move everything to one side. So what I do is 0 equals kx squared plus x minus 1, just moving the 1 to the other side. Now, because this is k, this is where it becomes a bit different. Because it's in terms of k, it's probably not easily factorizable. It's pretty hard to find out what the factors would be if we put it into 2 brackets. So we should know for a quadratic equation, we can use a quadratic formula. So whenever you have a quadratic equation and it has a parameter in it, just use quadratic formula. If you don't know what that is, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. I actually don't think that's on the formula sheet. No. So this is like a tech-free question. So you don't get your bound reference in like a tech-free exam or a tech-free SAC. So you have to, all like the knowledge and the formulas, it's either from your brain or it's from the formula sheet. I don't think this is actually on the formula sheet. So this is something you probably just have to remember and get used to if you probably need to know it. So yeah, it's just one of those things that you just have to know, but with repetition, you kind of remember. So what we do is we just plug in the values of a, b, and c. So this would be a, the coefficient of x squared. B would just be 1 because we have no coefficient. And then c is just a constant, it's negative 1. So we just plug in those things. So negative 1 plus or minus the square root of b squared, which is 1, minus 4 times a, which is k, times c, which is negative 1. And that is divided by 2a. So that would be 2 multiplied by k. Then we could just simplify whatever's underneath the square root. So negative 1 plus or minus the square root of 1 plus 4k, and that's all divided by 2k. So these would be your 2 solutions for x, one with the plus and one with the minus outside the square root. Cool. So for this question, we can see that this is 2 marks. Now, if I were a VCE examiner, I'm kind of thinking I'm looking for 2 key things when I'm marking this question, okay? And for tech-free questions, they're really peculiar about the working out, and you have to make sure that you include some specific lines of working out. So I would say for this question, this is like a common misconception. People think that because you have 2 solutions for x, it's 1 mark for each solution. It's actually not. It's just 1 mark for both solutions. The other mark maybe comes from one of these lines of working out, and most likely it'll be from something in this form, like that. Or it could be something like this. It's just like a preliminary equation that we have to find to get to our final solution. So obviously we needed to find this in order to get this, and then we continue from that using quadratic formula to get a full solution. So one of those equations would be equal to the other mark that we get. So it'd be this one or that one, and then plus our final solution, obviously. Cool. Anything to add? All right, cool. Okay, so part B, this is where it gets a bit harder. Give me 1 second. So what are the values for k for which f of x equals x has 2 solutions, then 1 solution, then no solutions? Okay, so in this question, we're kind of talking about the number of solutions for our given equation. Now, whenever talking about number of solutions and we have a quadratic equation, you guys probably know the discriminant. So in this case, we've got a parabola, and the discriminant in general is equal to b squared minus 4ac, and we represent it by the triangle symbol. So you've probably learned this for a couple of years now. If our delta is greater than 0, we have two solutions. If delta is equal to 0, we have one solution. Delta is less than 0, we have no solutions. So in this case, if we want to find two solutions, or the values of k for which we're given two solutions, then what we'll do is we'll find the determinant or the discriminant for our quadratic equation, and then we'll set it greater than 0 for two solutions. So that's one way, which is perfectly fine of doing this question. But there's actually a bit of a shortcut, and this is the way that I like to do these questions. And in some cases, we're actually not given a quadratic equation. So there might be a question where we might be given a cubic or a solution to like some sort of, I don't know, like trigonometric equation, where we can't actually apply the discriminant, because as you saw before, the discriminant only works for a quadratic equation. So whenever we're asked for like the number of solutions, the best thing to do, if we already know the solutions in terms of k, is just write down the solution again, just for reference. So -1 plus or minus 1 plus 4k, the square root of 1 plus 4k, divided by 2k. And we can think more algebraically about when the values of k give two solutions. So in this case, we can see that we've got two solutions, obviously, right? We've got x is equal to -1 plus the square root of 1 plus 4k over 2k. And then we've got the minus version as well. -1 minus the square root of 1 plus 4k over 2k. So you might be thinking, okay, well, we're already given two solutions. What does this question kind of mean? Well, for some values of k, we're actually not given two solutions. For example, if the square root value was 0, so let's say this was 0, this was 0, then both of our solutions would actually overlap. So that would only be one solution in that case. Another example, what if k is equal to 0? Well, we can't divide by 0. So in that case, we're actually given no solutions because all of our solutions are invalid. So we have to think more algebraically about when two solutions are produced, when one solution is produced, and when none are produced. So the plus or minus and the square root is really what's determining we get two solutions, whether we get one or whether we get 0. So in this case, we've got a square root. And if we want the square root to actually plus or minus a certain value, then what we want is we want 1 plus 4k to be greater than 0. Because what that would mean is that our square root value is positive. So we're actually plussing or minusing, an actual number. So we're actually given two literal solutions. Okay. So what we do is we have this in equation, 1 plus 4k is greater than 0, whatever's underneath our square root greater than 0. And then we just rearrange for k. So what we get is 4k greater than -1. K is greater than -1/4. Oh, so yeah, k is greater than -1/4. Okay, so that would be from the square root, what values would give us two solutions. Now, what a lot of people would actually get wrong in this question is that k is greater than -1/4 actually includes k is equal to 0. But there's actually two reasons why k can't equal to 0 in this case. First of all, we can't divide by 0. So that would give us no solutions if k was equal to 0. But also, if we look at the actual function that we have in our question, 1 over kx plus 1. If k was equal to 0, then we wouldn't actually have a hyperbola. This would just simplify to 1 over 0k plus 1, which is equal to just 1. So that actually wouldn't equal a hyperbola. So that's actually not valid in this case. So that's two reasons why k can't equal 0 for two solutions. So what we'll do is we'll just say, therefore, and I'll just write, k can't equal 0. So therefore, k is an element of -1/4 to infinity, and then we just exclude 0. So that's how we write the interval notation for this question. If you have any questions, just feel free to leave them in the chat or unmute. That's fine as well. But yeah, that's our solution to this question. So we're defining a set for k values to give us two solutions. Now, in this case, I wrote it in interval notation. So I have my start and my end value, and then I have my exclusion, obviously, of 0. Now, we could also write it as set notation as well. It's just whichever one's preference. Personally, I like interval notation. You're probably the same as well, yeah? Yeah, because you can see your start point and your end point. So it's really clear. And it's also easy just to exclude values because you could just do \0 in a squiggly bracket. Just another thing.
I've got a question.
Yeah.
Is interval notation necessary or is the inequality enough?
Inequality is enough, but you probably have to do like the proper notation for inequality. So for this question, what it will probably be is something along the lines of like, you've probably seen this in your textbook, like k such that k is greater than -1/4. And then you could probably just separate it with a comma, k can't equal 0.
Yeah.
That would be the other equivalent solution in set notation, sorry. And then for interval, it would be, what I wrote before, because so k is an element of -1/4 to infinity, and then you exclude 0. So these are like the two possible solutions. Either one is perfectly fine, whichever one you prefer. I think most people prefer interval notation because no one remembers like the notation for sets. They don't know like the squiggly line and things like that, but that's something that you have to include. So that's why people avoid that. Good question though. For this question, 1 mark for the final answer, obviously. 1 mark most likely for this line of working out, because this is the key part to get our full set of k values. That would be the 2 marks for this question. It's always important to look at the marks allocated to each question, because that gives you a really good indication about not only what lines to include in your working out, but how much roughly you should have. It's kind of a good guide. Even if you don't know what the marks are allocated to, it gives you a good guide about how much working out to include in your questions. Okay, so once we do the second part, the next parts, once we do the first part to this question, 2 solutions, the next parts become a bit easier. So for one solution, as I talked about before, we do it based on our general equation in terms of k, or our general solution in terms of k. So for one solution, we want the square root to equal 0, because then we're plus or minusing nothing. So then both of our solutions would overlap. So let's say if the square root was 0, right? It would be -1 plus or minus 0 over 2k. So our solution would just be -1 over 2k. That's obviously just one solution. So what we want in this case is for our k value to, well, not a k value, but our square root to be 0. So that's really easy. We just do 1 plus 4k is equal to 0. K is equal to -1/4. That's our solution for k for this question. Super easy. If you did it using the discriminant way, it would have taken you way longer. So don't use that way if you don't have to. Just use this way. 1 mark for your final answer. 1 mark for just saying 1 plus 4k is equal to 0. 2 marks. Awesome. Okay, so for no solutions, this one should be pretty obvious from the previous 2 questions. We just want whatever's underneath our square root to be negative, because whenever we have a negative underneath our square root, then we have an invalid square root. So therefore our solution wouldn't even exist at all. So what we say is 1 plus 4k is less than 0. So that's what's underneath our square root there. So then k, well, 4k is less than -1. K is less than -1/4. And don't forget to include k equals 0 as well, because that would give you, actually, I don't think we actually have to include that.
What?
K is equal to 0 to give no solutions. Should we? Because you get 1. I think for this question, this question we get k is equal to 0. Actually, no, let's just ignore that for now. That's actually not important. K is less than 1/4 for no solutions. That's just when our square root is negative. I think because k equals 0 shouldn't be part of any of them, because then our function is just not valid at all. So like it doesn't even matter in this question. Okay, so just k is less than 1/4. So if we wanted to write this as set notation, it'll be k such that k is less than -1/4. Or if you write it in interval notation, k is an element of -infinity to -1/4. Sweet. Oh, not squiggly brackets, but round brackets. Note that round brackets for interval notation means exclusive. So it actually doesn't equal at that point. Okay. So again, you could answer all these questions with the discriminant way, but it would take you, I would say, almost like double the time to do it, because you have to think about what your quadratic equation is, find a determinant and resolve it every time. I would say this way is much better, more conceptual, and it also works for non-quadratic equations. And that definitely has come up in SACs and exams that we've seen before, where you don't have a quadratic equation, so you can't apply the discriminant. Sweet. Any questions? Just leave them in the chat. Just like give it 30 seconds or so if you guys want to copy down this working out. 2 marks for this question are pretty obvious, actually, because we just talked about this before. 1 mark for that one, 1 mark for the final answer. So from this guide, you should be able to figure out whenever you have this type of question, when you're solving something, 1 mark for your final answer, rather, even if it's 1, 2, or 3 solutions, and then 1 mark for some intermediate line of working out, which is like the key to solving the question. I think there's something in the chat. What does it say?
How do you get 1 plus 4k?
For which part? Just like in general, for all these questions? Oh, okay, yeah. So our general solution to our equation was -1 plus or minus the square root of 1 plus 4k over 2k. So 1 plus 4k comes from whatever's underneath our square root. Actually, like, this is like interesting. The discriminant it's actually using exactly the same principle. You see how this, a lot of people don't know this, but underneath the square root is actually delta. You see that? B squared minus 4ac. So B squared minus 4ac actually comes from our quadratic equation. So instead of doing the same thing twice, we're just using our solution to figure out how many solutions we need. So instead of solving this again, we just solved it previously. So we just use whatever's underneath the square root as our determining factor for 2 solutions, 1 solution, and no solution. Does that make sense? Just give like a thumbs up in the chat if that makes sense. But again, like, you could do the same thing again, but what I'm saying is that you're just repeating the same process again. So it's not like the most efficient way of solving this question. And as I said before, it's not like, it doesn't work for all equations, because not all equations will be quadratic. Cool. Good question though, good question. Okay, so hopefully that's enough time to copy the solution. If you wasn't, and you want if you want to rewatch this again, we're recording it. So yeah, we'll share the recording with you guys. We'll just send the YouTube link via email, and you guys can just watch it anytime if you would like, just to get these solutions down and more thorough, like a more thorough watch of it. You can like pause it and things like that, or 2 times speed us if we're too slow. Yeah. Okay. So question 2. Okay, this one actually includes the CAS. So most people use the Casio ClassPad, so we'll use that in this case, but you could do exactly the same thing on the TI as well. The functionality is very, very similar between the two. Okay. If I bring up the calculator, can you see it, Hashan?
No.
Okay, wait, let me stop the share and start it again. I think because you should be able to see it now, yeah?
Yes.
Cool. Okay, so here's questions calculator. So calculator questions or calculator, just calculator exams in SACs in general. The working out is like vastly different to tech-free working out. I'd say while tutoring for the last few years and teaching with mind learning, the most common thing that people struggle with is figuring out how much working out to put down for exam 2 and CAS tests. Like the amount of working out you need is little, like very, very little. Okay. You just need key lines. You don't have to do any like hand working out or anything. Just like key line of working out and then answer. That's literally it. Yeah. So we'll go through like how much you actually need, but like it's much less than people think they need. Okay. So let's have a read of this question first of all. Let f of x is equal to x cubed plus bracket p minus 2 bracket x, where p is an element of R. So in this case, you can see, similar to the previous question, we have another parameter. In this case, it's p. Now, p, it's really important to figure out what your parameters are defined by. So in this case, it's all real numbers. Now, note it sometimes might not always be all real numbers. It could be a set of numbers, maybe all positive numbers, all real numbers excluding 0. But it's something to really note in these questions, okay? Because sometimes it's not just defaulting to all real numbers. It could be something else. And that's kind of key for answering these questions. Okay, so the first part, for what values of p is f of x strictly increasing for all real numbers? Okay, so I guess just like all strictly increasing, hopefully you guys know what that means. I was going to do a poll, like how many of you know what strictly increasing means, but don't worry. But hopefully you guys know it, but I'll just give a quick explanation anyway of strictly increasing. So if the graph is strictly increasing, it means as you move right on the graph, then the y value gets taller. So an example of this is like this graph here. Doesn't matter what the graph is. What matters is the shape. So if we take this x value here and this X value here, obviously you move to the right to get to the next point, and you can see that that point is higher graphically. Okay, so what strictly increasing essentially means is that this always happens throughout the whole graph for all real numbers. So anytime you go left to right, the Y value will always be getting higher. Okay, so this is for strictly increasing. Now, strictly decreasing is obviously just the complete opposite. So strictly decreasing is if you have a graph, then as you move right, it just goes downwards. So we could just draw like the reflection of this. If you move to the right, then you can see that the Y value always goes downwards. And this works for any combination of X values where one is bigger than the other. Okay. Any questions? Leave them in the chat. In this question, it's not that important, but the proper definition for strictly increasing is that if B is greater than A, then the function of B, or essentially the Y value at X equals B, is always going to be greater than the Y value at X equals A. So that's kind of like a proper definition for strictly increasing in terms of like general variables like that. Wait, what? Oh, yeah. Sorry, yeah. So like, for example, this would be A, this would be B, like as coordinates. So sorry, X equals A, and then X equals B. So like, you can see that A is less than B as a number. And when we move like to the right, because B is greater than A, then you can see that the Y value gets bigger, like it gets taller. Okay. Obviously, just the converse for strictly decreasing. If B is greater than A, then F of B would be less than F of A. The most common misconception for strictly increasing, and like so many people get this wrong. Whenever there's strictly increasing questions, people always get this part wrong. Let's just sketch like some other example. I'm going to do X cubed, okay? So the graph of Y is equal to X cubed. We should know that X cubed is flat at the middle, at the point of inflection. So what flat means is essentially like a gradient of 0. Now, a common misconception is that if it's flat, then it's not strictly increasing or decreasing anymore, but it actually is, okay? And actually, I've thought that for a long time as well, because the textbook wasn't clear on this. And yeah, that's why the textbooks, like kind of, you can't rely on them all the time, and they don't go into a lot of detail. But if you have a gradient of 0, that still counts as strictly increasing. And I'll just show you why. If we just zoom in on this graph, oh, shit. Where'd it go?
You gotta zoom out. It's always happening.
Yeah, I know. Okay, so if we zoom in on this graph, and let's think about what I said before. If you move right, then your Y value goes up. And even if it's a 0 gradient, that still happens. So if we think of the point just before 0, let's just say like negative 0.1, right? And if we move to the right to 0, it still goes higher, because at x equals -1, it's going to be a bit more negative. And at x equals 0, obviously x cubed is just going to be 0. This is the equation of Y equals x cubed. Then if you move to the right again, it still goes higher. It's only flat at that one point there. So you're going to move through it. And as you move right, it's still going to get higher, even though it's a flat gradient. The problem is if you go like this. This is when it's not strictly increasing. If it's like this, right? Because at this point here, that's when it turns downwards. So when it turns downwards, it's not strictly increasing anymore. It's actually decreasing. And the best way of telling that is just by, you see a negative gradient. This is obviously going downwards like that, like a negative slope. So at that point, it's not going to be strictly increasing anymore. It's actually going to be decreasing. So that's when it's not strictly increasing anymore. Does that make sense? Yeah. Is that all good? Anything to add? No. Cool. Okay, so let's have a look at this question where we're asked for the values of P for which f of x is strictly increasing for x is an element of R. So keep the definitions in mind because they're really important when considering this graph. So can you see the calculator? Yeah. Okay. So when I have a function and it's got a parameter, what I really like to do is define it because it makes it easier. But whenever we have like this sort of problem where we need to find the proper values or the set of values of P for something graphically to happen, in this case, is strictly increasing, what I like to do is use graph and table. Now, if you guys probably used graph and table before, there's actually a really cool feature on this. So what I'll do is I'll type out my equation, x cubed plus bracket p minus 2 multiplied with x. That's just what f of x is. Now we tick this, and you might be thinking, I can't graph that. That's got a variable in it. But we don't use this first button for a normal graph. We use the second button. You can see that it's got like Heshan calls it a shaky parabola because it looks like it's like a parabola and then it's like shaking around like with the dotted lines. But yeah, use that button. You can see when we use this button, there's actually a really cool feature on this where you can change the values of P, and that shows you what the graph, how the graph changes with the P values. Okay, so we can see as you decrease the values of P, something happens, you increase it, something else happens. Pretty cool feature, I would say. And I wouldn't be able to answer this question without this, and probably most of you wouldn't either. So it's really important to understand this feature, and it works for any graph with a parameter or a variable in it. So you can change the values of P, and I think you call it dynamic graphing. Yeah. So dynamic graphing is what we have right here. So dynamic graphing is essentially like, yeah, you have a parameter, that parameter changes the graph, and we can see graphically how different values affect the graph. Essentially what I'm looking for is the point where the graph is strictly increasing, and seeing if I decrease P from that value, what's going to happen? If I increase P from that value, what's going to happen? So if I decrease P, I can see I'm getting less strictly increasing because my peaks are getting higher. So I can see that in this middle section here, from about y equals 3 to y equals -3. Can you see the cursor? Yeah. Yeah. So from here to here, it's strictly decreasing, obviously not increasing. If I increase the values of P, I get closer and closer to that graph where the peaks are smaller, and I'm getting to the point where it's getting more flat. So I'm looking for that range. So I can see when P equals 2, I'm pretty much perfectly flat at the middle, okay? And the best way to confirm this, obviously, I'm just looking at it. It's not 100%, but the best way of confirming that it's flat is by literally subbing P equals 2. What's happening to the screen? Is that fine?
You stop sharing it, close it, open it.
Okay, 1 second, guys. Technical difficulties. What's that happens when you share more than one thing at the same time? Can you see the calculator?
No.
Brother.
You got to close one and open it again.
How you can see now?
Yeah,
I'll close one note.
Yeah. I'll see if you got the same issue.
Yeah. Sorry, 1 second, guys. So I'm just restarting the OneNote. Does that always happen to you?
Happens sometimes.
Yeah. I think it's when you share the calculator at the same time as the OneNote, like you're sharing multiple programs. Let's get back on this. Okay. Can you see the calculator?
Yes.
Okay, cool. Okay. So essentially what we found when we were dynamic graphing was that P equals 2 causes it looks like a flat line. And the best way to confirm this is just by substituting P equals 2 into our equation and seeing the result that we get. So f of x when P equals 2 would be x cubed plus 2 minus 2 of x. So 2 minus 2 is obviously 0. We're just left with x cubed. And as the explanation before, we use x cubed as an example, and we knew that that was strictly increasing because at 0, 0, it's flat. So that's when it's fine to be a flat line. It's strictly increasing for all real values. So find the values of P for which is strictly increasing. We know it's going to start from 2, or 2 is one of our values of P.
Okay, question.
Yeah.
And we just say this again. For P, do you use the key from the variable section or the ABC section? Do you know?
Oh, no.
When you go to your typing in,
yeah.
Typing in P,
yeah.
If you go to the main,
keyboard.
Main screen,
the
variable ABC.
Yeah, so this one here.
Yeah.
That's the same. Yeah, use this one, the normal keyboard.
Yeah, okay.
Yeah. I think I've never tried the other ones, to be honest, but I just use these ones. It's always worked.
I think they both work.
Yeah, so I think it's just to make it a bit more prominent. It's a different. It's italic, right?
Yeah, it's italic versus bold, but
yeah.
They both work.
Yeah, they both work. So don't worry about it. Just use one or the other. I've used a normal keyboard up until now, and it's been okay. We just use the normal one because when we type it on our keyboard, that's what comes up. But yeah, X, Y, Z, ABC, it doesn't matter which keyboard it comes from, as long as it's a variable, it's fine. Cool. So we see that P, let's go back on the graph. P is equal to 2 causes our flat middle line. Did someone else ask a question?
Why is 2 the starting value?
Yeah, so I saw when P was less than 1, it's it's not strictly increasing anymore because you're dipping in the middle, but the P is equal to 2, the P value of 2 from this graph is the point where it gets flat at the middle. So that's the verge of that value. to make it flat in the middle. Is that what she means? I'm not too sure.
Yeah. So pretty much if you start going less than 2, you see
If you
pretty much
start
if you start going less than 2, you see that the graph starts going like up and down and back up, right? If you get to 2, that's when exactly the graph is going to be flat. And if you go more than 2, then the graph doesn't go flat at 0. It actually starts going at like a more of an angle.
Yeah,
right?
It goes like more vertical.
Yeah, exactly. So it turns into like more of like a diagonal graph. But if you go before 2, you're going to see that the graph starts going up and down and up again. And that means that it's not strictly increasing. So that's why the starting value is 2.
Yeah. Cool. Yeah, great explanation. Just let us know in the chat if that's all, it's all good. Yeah, so pretty much from this graph, we see that P equals 2 is like the verge of where it's flat. And we can see when P is larger than that, then it's obviously strictly increasing, like it's getting more and more steep at that point. So that's fine. So the set of P values to make it strictly increasing. And the key thing is we're strictly increasing for all real values. So it's not just strictly increasing for like a small set of X values, it's for the whole graph. So for values of P would just be greater or equal to 2. That's pretty much it. Or just make your point of notation. Or you could say P is an element of 2 to infinity. The key thing in this case, have a look at the chat because I can't see it. Yeah. But P is an element of 2 to infinity. Just make sure that we include 2 because we saw that 2 is like the verge of where it's flat. So if it equals 2, it's fine. If it's greater than 2, it's also fine. So yeah. Cool. Yeah, cool. Sweet. Okay. So from that, we know that P is greater or equal to 2 will cause a strictly increasing graph. Sweet. Okay. So the next question, solve f of x equals f inverse of x for x. Okay. So what we do is, we just want to solve this equation. Not too hard, but in this case, we've got a bit of a unique situation where we have a cubic. I want to find the inverse of it. So we should know for inverses. Mind you, I'm just like thinking aloud right now. For inverse, we have to swap x and y in general. So in this case, what it's going to be is x is equal to y cubed plus p minus 2 of y. And then we just solve for y. So let's just try to do this with the calculator and see if it works. And just solve for y. Heshan, can you see the calculator?
Yes.
P minus 2 of y. Now, a note before continuing this question, when we do dynamic graphing, like you saw in part A, the variable P will actually save in variable manager. So click the cog at the top, go to variable manager, go to main, and then get rid of P because P is actually saved as 4. And that was the last value we graphed for. So delete that because that would actually affect our equation. So now P is just a variable, just doesn't have value associated with it. So now our calculations won't get messed up from when we're solving for y. So let's try and solve for y. Oh, whoops. No, I can mess off that. Interactive, advanced, solve for y. I'm sure TI users probably know how to do this as well. Just solve for your value. But you can see that this actually doesn't work. Okay. That's because our equation is too complicated, especially with the parameter, but also because we've got a cubed factor, like a cubed y variable. So we actually can't find the inverse. Okay, can't find the inverse. How do we even solve this equation? Well, there's a shortcut. Let's forget this way for a second. Whenever we want a graph to intersect with its inverse, we can actually solve the equation f of x is equal to x instead. And this is because a graph and its inverse will always intersect along the line y is equal to x. So if we think of like a basic graph and its inverse, the most basic one I can think of is this x squared and then the square root of x. They're inverses of each other. So this is x squared, this is square root of x. So these are inverses of each other. Now we can see that these actually intersect along the line y is equal to x. So we can see we've got one intersection there, one intersection there as well. So for in general, a graph and its inverse will always intersect along the line y is equal to x. So whenever we want to solve a graph and its inverse equal to each other, like find the x solutions, then we could easily do this by just solving f of x is equal to x instead. It's a different equation, but it gives us the same solutions, and that's what we're after. So in this case, what we'll do is just write x cubed plus p minus 2 of x is equal to x. And simply just using the calculator, solve this for x in terms of p. So this question, I could just say x cubed plus p minus 2 times x is equal to x, and just solve for the values of x. Interactive advanced solve, and this should solve in terms of p. Yeah, in this case, it gives us our 3 solutions in terms of p. So we've got x is equal to 0, x is equal to negative square root of, I forgot what it was, 3 minus p, and then x is equal to positive square root of 3 minus p. So we've got 3 solutions here for our one equation. So I think that probably 1 mark would be for one of these 2 lines here, and then 1 mark definitely for your final answer. Okay, I'll give you guys a couple of seconds to write that. But just a summary, a graph and its inverse will always intersect along the line y is equal to x. So sometimes you can't find the inverse, like in this case. So we'll just solve the equation f of x is equal to x, and we'll get the same solution.
We just got a few questions about the TI Inspire, like variable graphing on the TI Inspire. So it's the same thing. When you type the function in on the in like the graphing area, you can go to like the menu actions and then insert slider, right? You can go to actions and then insert slider. That's going to ask you what values you can modify the values, like the minimum, maximum values, and it's going to create a slider. So you can slide it very similar to how Adrian did it on the CAS. Yeah.
Yeah. Cool. Yeah.
We've got like some other questions.
Yeah.
How is question 2 CAS a 2-mark question?
Question 2? Like, yeah, part B, right? Well, in this case, D, but the second part, yeah? Okay, so 1 mark would be recognizing the fact that f equals f inverse is the same as this. That's 1 mark purely from that.
Oh, part C, sorry.
Part C? Oh, like the first part of this question?
Yeah.
Oh, probably like I reckon like probably for like either the 2 endpoints, I guess.
Yeah.
Like marks don't necessarily relate to like the lines of working out. It's like more of an indication of like the difficulty of the question. So obviously that question required like a lot of thinking. So in that case, like that 2 marks would be allocated to that rather than like lines of working out. But I would say most likely 1 mark would be for recognizing 2 is the start point. And then another mark would be for 2 is inclusive as well. Because as I said before, a common mistake is that 2 is actually not inclusive. So a lot of people would just do p is greater than 2 and they would receive 1 mark.
And it's also really dependent on how your teachers like to make your SACs. So that's also another really big thing.
That's like another thing. Yeah, that's another thing altogether. Like SACs are like it depends on the teacher. Some teachers can be like clueless.
Yeah,
and like just
might make that a 1 mark question.
But like if you're structured, this would be like an exam type question. So in an exam, this would be 2 marks, and 1 mark would be for recognizing 2 as like the starting value, like the key value, and then also recognizing that 2 is inclusive as well. Anything else in the chat?
Is there any way to find the inverse?
No, just not. No, there's no way.
So the question was, is there any way to find the inverse?
Yeah, so like, and the answer is no, because we've got p as our parameter and we've got a cubic equation. So I guess like, there's no way of finding the actual rule for the inverse because like the original equation is just too complicated. Yeah. Don't worry about like why you can't find it. Just know that like some equations you can find the inverse, some equations you can't. It just purely depends on the equation that you're given. If it's like a basic equation, then you'll be given it. But if it's not, then you won't be able to find it. I think like a rule of thumb for knowing if you can find the inverse or not, like this is what I've just noticed from going through, like don't quote me on this, but what I've noticed so far throughout learning this is that because in this case, we have like 2, you see how y is included twice, we've got y cubed and then we've got just y by itself as well. I think when you have more than 1, then you can't just rearrange simply because we've got 2 occurrences of y, we can't actually rearrange. But let's say if we had like x is equal to y cubed by itself, we should know that we could just rearrange this as y is equal to x to the power of 1/3. So that's like a slightly different one where we only have 1 occurrence of y, just the y cubed, and then we could just rearrange directly. Okay. Cool. Okay. So 3 solutions for x in this case for f equals f inverse. Now, last part, which is the hard part. And usually the last questions are always the hard ones. Hence, find the value or the values of P for which F equals F inverse has 3 solutions. Okay, so this is very similar to our question in the previous part. We want to find the parameter value for a certain number of solutions. And again, you might be confused because we're already given 3. We have x equals 0, x equals negative square root of 3 minus P, and the positive square root of 3 minus P as well. So like, what's the give? We're already given like 3 solutions. Now, as I said before, square roots cause a bit of an issue with solutions. And sometimes for square roots, they don't exist or they overlap. So in this case, let's say like this square root was negative, like underneath the square root was negative, then this square root wouldn't exist. And then same for this one. If it's underneath the square root was negative, then it won't exist. We should know that square root of negative values doesn't happen in methods. It's not real. But if you do special, it's a bit different. In this case, we're doing methods. So square root of -1, undefined. It doesn't give an actual solution. Okay. So just note, when I have 3 solutions, it doesn't necessarily mean like 3 general expressions. It means the actual value exists and they're unique. Okay. Also, like I mentioned a keyword before, unique. So although like if these square roots still exist, right? But if they equal 0, let's say that the square root of 3 minus P was equal to 0, then this solution would be the same as this solution. They would both be 0 because it's just plus or minus 0. And that would also be the same as that one there because all 3 solutions would be 0. So there's some P values which cause some solutions, some P values which cause no solutions. So that's what we have to kind of figure out in this question. For what values of P do we get 3 unique solutions? So hopefully from the previous question, you guys have some sort of clue for this. So essentially what we want is we want this to be one solution, this to be another unique solution to the first one, and the third one to be another unique solution apart from that. So we can see that these would be unique solutions because it's plus or minus of each other, but only if the square root is positive. So in this case, we want 3 minus P to be strictly greater than 0 because we want a positive square root, which would result in 2 more unique solutions, 1 from each square root. So in this case, 3 minus P is greater than 0. And then we could just simply move the P to the other side. 3 is less than P, or we could rewrite this as P is less than, P is less than 3, just swapping it around. Okay, so most people would stop here. Hopefully you can get to this part, but if you can't, that's okay. We're learning. So P is less than 3, but we have to consider the equation that we're trying to solve. F equals F inverse of X. We have to think about when an inverse actually exists. And in this case, it's not so clear because we have P as our variable, like as a parameter. So let me just remind you that F of X is equal to X cubed plus P minus 2 of X. And I'll guarantee you like 95% of people will just overlook this. They will just think that these are your 3 solutions to the equation, okay? But when does an inverse actually exist? What you guys should know, and if you don't, I'll show you now, a function has to be 1-to-1 for it to have an inverse. So for example, let's just move to the slide here. Oh, it's happening again. 1 second, sorry. Does that always happen? Sorry, 1 second, guys. Let me just share my screen. Cool. So let's just draw this again. So a function only has an inverse when it's 1-to-1. So if we drew a normal parabola that's not restricted, we should know that this would be the shape of the inverse, but this is actually not a function because it's not, it's like 1-to-many. If we do a vertical line test, we see, yeah, it's a relation. So whenever we have a function and we want to find its inverse, it always has to be like 1-to-1. So that's why for like parabolas, we would always restrict it first. Let's say like that branch would be just the right side, and then the inverse would just look something like that. So you should notice that this is actually 1-to-1. And then the result would also be 1-to-1. So the key thing to note for this question, or like this concept, is that functions must be 1-to-1 to have an inverse. Okay. And okay, so 1-to-1 to have an inverse. Now, if they're 1-to-1, Another way of saying that is that they're strictly increasing or decreasing. So this is the same as strictly increasing / decreasing. Because if we think about what a strictly increasing curve is, as you move right, the y value is always going up. Or if it's strictly decreasing, as you're moving to the right, the value is going down. That's the same as being one-to-one, wherever like your y values don't overlap. So an example where we won't have an inverse is if we have a cubic like this. This is obviously not one-to-one. This would be a many-to-one function. And it's also not strictly increasing. So strictly increasing, it's not. And obviously this doesn't have an inverse because the shape would just be whack as. Yeah.
The question is, could we restrict the first question to make it one-to-one?
No, not if the question doesn't say to. Okay, so I think, was it a question in the chat?
Yeah.
Okay, so the question in the chat was, can we just restrict the original function to make an inverse exist? No, because the reason why is because there's actually certain values of p for which it already exists. So if the question said to restrict the domain to make the inverse exist, that's when we would do it. But if the question doesn't say that, just I guess you just can't do it because it's kind of just like making up your own question. So yeah, don't do that unless the question explicitly says that. But in this case, like the reason why I brought up the strictly increasing thing was that we can make it strictly increasing, or we can make the function and the inverse exist by setting values of p for which it's strictly increasing only. And we actually found that in part A. P was equal, just use a different color. P was an element of 2 to infinity, inclusive, to make the function strictly increasing. So let me just write this down as like a thought process. So we want f inverse to exist. And if f inverse exists, we want it to be strictly increasing or decreasing. Okay. And strictly increasing or decreasing, what happens when it's strictly increasing for this function, was when p was an element of 2 to infinity. Okay. So we could see that for like the previous set of p values that we found in this question, p was less than 3 to be valid. But if p is less than 3, like let's say if p was 1, that wouldn't make sense because then our function wouldn't be strictly increasing. Hence, we wouldn't have an inverse function. Hence, we wouldn't have any solutions to solve this equation with because the inverse function wouldn't even exist. Okay. So even though there might be a rule for it, the equation won't actually be valid because the inverse function doesn't exist. So that's an important factor in this question where we have to note that there are some values of p for which the equation is just not valid. So that's why when we're looking at like these solutions are good because they're general solutions, but for some values of p, they won't be valid at all, even though we might have 3 unique solutions. Just the equation doesn't make sense at all. So we can't include those values of p. So in this case, p would be an element of 2 inclusive to 3 exclusive. So we can see that p is less than 3 and then p is greater or equal to 2. We just found the intersection of them. So obviously that's just when p is in between 2 and 3, but we keep the endpoints the same. So we can see that p could be equal to 2 for this one. It's inclusive. And then for this one, it's exclusive because it has to be strictly less than 3. So that's how we get square bracket 2, round bracket 3. Or you can write this as p 2 is less than or equal to p, which is less than 3. This style of question has been asked before in exams, and these types of questions where it's like multifaceted and it has multiple concepts that are kind of hidden, they're the ones that like people get like only 2% of people get full marks or something like that. Like there's some ridiculous ones. I think I have seen something like this before, but I don't know where it's from. It's from like some sort of exam too somewhere, but it was a question where like a function was equal to its inverse and you had to find multiple values for a parameter to have a certain number of solutions. But there were some values like this question where the inverse function didn't even exist at all. And a lot of people overlooked that. Can you see the calculator? So I'm just going to like sketch something. If we sketch this for like, let's say p was equal to like something that was outside this range, p was equal to 1. So like, let's just copy and paste this equation. Also, any questions, just leave them in the chat. Feel free to. So I'll say p is equal to 1, and I'll graph this. And then also there's actually like a quick way to sketch the inverse function, just inverts it. So you can see an inverse graph sketch, but I won't use the word function because obviously it's not a function. We've got the 3 intersections. We've got one there, one there, one there, but our inverse curve is not actually a function. So that's why we still get 3 solutions, but inverse function doesn't exist because it's not a function. So we can't actually include that. Does that make more sense? Like using the graph? But like, let's say if we had like, let's clear this graph. And we had like P is equal to like, let's say 2.5. That's in between 2 and 3. We sketch this and we sketch an inverse. Sketch inverse. We can see that we have 3 solutions now. If I zoom in on this. So we have 3 solutions now. And you could also see that now our green curve is actually a function because it's 1-to-1. So 3 solutions and our function is actually 1-to-1, which causes an inverse function to also be 1-to-1. So in this case, it would be like a nice example or exemplar of when you would actually get 3 solutions and our inverse function existing. I guess the main thing to take away from this question is that obviously the concepts, but in terms of exam structure, exam questions usually don't ask things for no reason. So in this case, part A was asked for a certain reason. We asked for strictly increasing, and in the back of your mind, you have to think about why they asked for it to be strictly increasing. Is there a point? Obviously there is a point because strictly increasing functions are 1-to-1, which means that inverse functions do actually exist.
Question, wouldn't 3 minus p be greater than or equal to 0? Question.
Good question. Yeah, so the question was, would 3 minus p be greater or equal to 0? No, because imagine if 3 minus p was equal to 0, and obviously 3 would be equal to p, right? If we had x is equal to 0, x is equal to, let me just write down the solution so I could show you. Positive square root of 3 minus p. If p was equal to 3, then what would this solution simplify to? Negative square root of 3 minus 3, which is just 0. What would this solution simplify to? Square root of 3 minus p, 3 minus 3, it's obviously 0. 3 solutions, but they're not unique. They're all the same. So it's not actually 3 solutions anymore. It's actually just one that overlap 3 times. So
another question. The question asked for 3 solutions. So what's the answer for the 3 solutions?
Well, there's no actual answer. The question's asking for the values of p to get 3 solutions. So obviously, depending on the values of p, you're going to get 3 different solutions. For example, if you had 2.5, you would get 3 unique solutions. That would be different than if you had p equals 2.7 or p equals 2.2. All of them would give 3 solutions, but 3 vastly different solutions, just depending on whatever value of p you're substituting in. But as long as p is, as long as p is in between 2 and 3, then you're going to get 3 solutions. But in this question, it's not asking for the actual solutions. It's asking for the values of p. So that's actually a good point you pick up. Like, that's actually a good time to raise this point. We have to actually read the question and make sure we're answering the question that it directly asks us. Because it's not asking for the solutions. It's asking for the values of p to give 3 solutions. So if you just find the solutions, there's no point because first of all, it's a waste of time. Second of all, you're not answering the question appropriately.
What good question?
Yeah, no, still a fair question. Like, it's hard to tell, like, because you don't understand like exam structure. Like, I mean, VCE exam, because VCE exam structure is like very particular. So again, they structure things appropriately and they ask questions like very sneakily. Yeah. So that's like, like what we kind of like focus on when we're teaching is, I guess, understanding the exam structure and knowing all those like little tips and tricks, because we've gone through the process before. We've done heaps of exams before. We've like been tutoring through different exam periods. So like we know all the different tips and tricks that they ask, and like all like little sneaky things like this question has, where like people wouldn't usually get it. And if it's the first time doing exam, you won't get it. But do it 10 times, do it 20 times, do it 50 times. You're eventually just going to know. You're just going to have like a second nature instinct for it. Cool. And like this is like just one trick, right? There's like so many more, but like that's what our kind of like course kind of goes through. It's like, time and time again for each different topic, going through those tricks, understanding them and how to overcome them, and really like get you from, like if you're going for 40, get you to the 45, because like these are like the little tricks that like push you to the next level. It's like small margins in between, you know, like getting a good score, getting like a really, really good score. So yeah, a lot of people don't understand that. Like that's what we're like that's kind of like what we're, yeah, that's like our specialty. That's what we really focus on, like getting that 1% extra that you wouldn't be able to otherwise, and like, you know, providing that expertise. But yeah, hopefully you guys enjoyed the question so far. If you're liking it, yeah, feel free to stick around for like the last question. After the last question, we're going to go through like, yeah, how to continue with us. If you're really liking the seminar, we host these like once every 4 weeks or so with that course. It's like one for every topic, but we got permission for our, you know, private one to go through VCA questions, which are obviously, you know, very, very applicable to what you're going to be doing. Like it's like exact replicas of what you'll be doing. So if you're more interested in that, then stick around for the end, and we'll speak about more details for that. Oh yeah, for our private students who are already with us for today, thank you for coming. Thank you for your support. We'll actually be hosting our private one next week. So don't worry, like we're going to go through it more thoroughly. Yeah, VCA exam questions. We're going to like pick and choose them from like topics from that you would have already covered with us. Yeah, we'll have like a 1 minute intermission just to like rest up. We'll give you guys a break. Yeah, check your phone, go to piss, and then come back, and then we'll do the last question. All right, so hopefully you guys are up to date with all your notifications on your phone now. So we're going to go over the last question. So a roller coaster is modeled by a polynomial function where the y coordinate represents the height of a roller coaster in meters and the x coordinate represents the horizontal distance of the roller coaster in meters. Negative y coordinates represent the underground portion of the ride. So the roller coaster starts at the origin, goes underground for the first portion of the journey, and exits the underground tunnel at a point of inflection at a horizontal distance from 10 meters from the origin. So there's a lot of information here. I'm just going to highlight some of it. So I see that there's a point of inflection at a horizontal distance. I'm just going to highlight that. The roller coaster then continues up and comes back down to form a local minimum, right? At a horizontal distance of 20 meters from the origin. The roller coaster stops at 20,0. So these types of questions are actually more modeling task questions, and they can actually ask this in the next SAC that you guys are probably going to have is going to probably be like application or modeling task question. And they like to chuck in questions like this, where even if you do have access to your calculator, it doesn't really help because there's really nothing that you can do with your calculator to help you really understand what the graph is going to look like. So what we have to do is, so question A, find the equation that models the roller coaster. So we have to find a polynomial function which tells you the rule of what this roller coaster is going to look like. But before we start that, we have to understand like the basics of what it means about like point of inflection, what that means, what does a local minimum
When do we form one of those? When do we cut through as an intercept on the x-axis? So we'll just do like a little review of that before we start the question. So we have, if you look at these three examples over here, I have y is equal to x minus 1. I have y is equal to x minus 1 squared, and y is equal to x minus 1 cubed. So if you solve this just for x, you're going to realize that the three solutions are going to be the same, right? The intercepts, the x-axis intercepts are going to be x is equal to 1, x is equal to 1, x is equal to 1 here, right? But the difference between these three functions is that the first one is raised to the power of 1. The second one is raised to the power of 2. The third one is raised to the power of 3. And that completely changes what the graph is going to look like, right? The first one is going to be like a linear graph. The second one is going to be a quadratic, so parabola. And the third one is going to be a cubic function. So whenever we're sketching this, we know that x is going to be equal to 1. So we know that it's going to cut through here, right? So this is just like a linear equation that you've learned. And the trick behind this is whenever you have 1 as your power, you know it's going to cut through that x-axis intercept. For the second one here, we have x minus 1 squared. So that's just a normal parabola. Y is equal to x squared, but it's been shifted to the right by 1 unit. So x minus 1 squared, that's just a normal parabola, but it's been shifted and it's going to, well, it didn't really bounce there properly, but it's going to bounce on this x-axis, and that's going to be 1, 0, 1, 0. And then this last one, x minus 1 cubed, that's just going to be the exact same x-axis intercept, but it's going to be a cubic, right? So it's going to inflect at that point over there. So as you can see, whenever we have 1 as the power, it's going to cut through it. Whenever we have 2 as a power, it's going to bounce on it. And whenever we have 3 as a power, it's going to inflect. So those are the three different things that we can have. If we look at an example when they ask us to sketch x plus 2, x minus 1 squared, again, we can use the null factor law to solve this for x is equal to -2, x is equal to 1. But I know that at -2, since the power is 1, it's going to cut. And I know at x equals 1, since the power is 2, I know it's going to bounce. So it's going to cut through here, bounce on this, and then continue up, right? Something like that. So now that we know that, if we go back to this question and try to understand what they're saying, right? So it says the roller coaster starts at the origin, goes underground for the first portion of the journey, and exits the underground tunnel at a point of inflection at a horizontal distance of 10 meters. So there's two things they say. It starts at the origin. So if it starts at the origin, it means that it's going to cut through the origin. So I know that x is equal to 0 is going to be one of our solutions. So I'm just going to write x multiplied by a point of inflection, right? So it goes underground for the first portion of the journey and exits at a point of inflection at a horizontal distance of 10 meters from the origin. So a point of inflection, we know that that's going to be raised to the power of 3. So a point of inflection, x minus 10 is what we do here, because x minus 10 as the factor, if we solve this, we're going to get x is equal to 10. And then this power of 3 is just going to say that it's just going to inflect, right? After that, it continues to go up and comes back down to form a local minimum at a horizontal distance of 20 meters from the origin. And the roller coaster stops at 20, 0. So if we form a local minimum, that pretty much means it's going to bounce on the x-axis. So what that means is x minus 20 squared is going to be our other factor. Because if we solve this bracket over here, we're going to get x is equal to 20. And then when we square it, it means we're going to bounce, right?
Yeah, I've got a question.
Okay.
Because it said local minimum, is the equation going to be any different? Like, is that factor going to be any different whether it's a local minimum or maximum? Like, or is it just going to be squared regardless of what type of turning point it is?
Well, the thing is, if it's going to be a local minimum or a maximum on the x-axis, it's always going to be squared, right? Yeah. But if it's not on the x-axis, it means it's just like a normal turning point.
So these factors only come from intercepts. But the reason why they're raised to different powers is not because the graph has a point of inflection. It's because our intercept is a point of inflection at x equals 10. Yeah. And then our intercept is a turning point at x equals 20. Yeah. That's the only reason why we model these. Yeah, exactly. So there might be a random turning point like like at, let's say 2,2, right?
Yeah.
It doesn't matter though, because that's not going to help us model our equation, because our equation modeling is purely from factors that cause x-intercepts.
Yeah, just like the three examples we had here, it's happening at the it is happening at the x-intercepts, right? It's cutting at this x-intercept, it's bouncing on this x-intercept, it's inflecting on this x-intercept. So exactly the same thing we have here. It's going to inflect first, and then it's going to turn. But before that, it's going to cut through 0 because it starts at the origin, right? So we pretty much have modeled all of our intercepts and our turning points and our cutting points and our bouncing points, right? The last thing is they give us this little bit of information here, and they tell us that it's known that the roller coaster passes through the point 5, negative 225 on 16. So the reason they say this is because you can have different intercepts, but you can have a different dilation factor at the front. So this question actually has a dilation factor at the front like this, and A is what we have to solve, right? So the equation that we have so far is just y is equal to ax, x minus 10 cubed, x minus 20 squared, right? And now we have to find the value of a in order to find our dilation. So
what dilation means essentially like this?
Oh yeah, so pretty much if I was to just use this as an example, you might be thinking like, why do we need the a, right? So if we have another equation, I can have the exact same intercepts, but I can have the equation looking something like this. Right? And we have the exact same x-axis intercepts, but in this graph here, we have a different dilation. So the different dilation pulls it up or pulls it towards the graph or pushes it away from the graph at a different rate compared to the blue function. So even though we have the same intercepts, we can have different dilations, and that's what we're trying to find here. So yeah.
Say like the A can also reflect like the reflection.
Oh, yeah.
Let's say if our A value was negative, right?
Yeah.
Our things would still make sense, but like it would just be, you'll still have like your turning points and your appropriate intercepts at the same point, but you could have like a reflection as well. And that would just be represented by a negative dilation factor.
Yeah, exactly. Yeah.
And like when you, like, do you know how we're given the anchor point? 5, negative 20, 225 over 16. Like when we substitute that in, it'll appropriately determine if it's positive or negative. We don't have to actively make it positive or negative.
Yeah.
It would already be accounted for with that point.
Yeah. And
Exactly.
And then at that point, we know how to sketch the graph.
Yeah.
So we don't have to worry about all those things about it being negative or a positive right now, because when we substitute in 5, negative 225 on 16, it's just everything's going to figure itself out. So we have your X and your Y coordinate here. So I know that negative 225 on 16 is going to be equal to A times X, and all the X values are going to be 5. So A times X, 5 minus 10 cubed, 5 minus 20 squared, right? And then at this point, all you have to do is just chuck this into your CAS, solve this for A, and then you will realize that your answer for A is, I'll just do it on the CAS real quick. Can you see the CAS?
Yeah.
Okay.
So I just quickly ask, why is, just repeat it.
Yeah.
Why was the X at the front here?
Why was the X at the front?
Of the equation.
Okay. It doesn't matter the order of the intercepts, but if you're asking why. Okay, yeah. So we know that we start at the origin, right? So if I was to just sketch this, just like off the top of my head, I might just use this graph over here. So they say that we start at the origin, we go underground for the first portion of the journey, and then we exit at a point of inflection. We go up and then we come back down to form a local minimum like that, right? Yeah, it was a pretty bad graph, but you get the point, right? So we have a point of inflection here, we have a turning point here, but if we don't worry about any of the restrictions that the roller coaster has, this graph would have continued going through here, right? So we have a section here, or not a section, like a really interesting point here. We have an interesting point here and an interesting point here, which we can use to model our equation. This is going to be your inflection. This is going to be your turning point. But here at the start, that is just X minus 0. If you wanted to have it as like as a bracket, which makes more sense, right? Because if I had X minus 2, you would know that X equals 2 is a solution. But the reason the X gets confusing is because we just have it by itself. But if you had X minus 0, it would make sense. Oh, it's going to happen at 0. So it's going to cut through 0. Pretty much whenever it just cuts through 0, we have X as one of our factors.
What if like it was a turning point at X equals 0? What would it be instead? A turning point.
Oh, okay. So if there was a turning point at x equals 0, right? The factor would be x squared.
Yeah. So it'd just be like x minus 0 squared.
Yeah.
That's how I think about it.
Yeah. You can
Obviously,
have,
I would just simplify to x squared. And that's why we write it really concisely at the
yeah,
start.
you can have x minus 0 squared. But we don't have the 0 because it's nothing. So that's why we just have the x at the front. So hopefully that made sense. I'm just going to continue with this, putting this into the calculator. So we have negative 225 on 16.
So what exactly are you doing now?
I'm substituting this negative 225 equals a times 5 times this equation into the calculator in order to solve for a.
Yeah. So you're just like substituting the point, right?
Yeah.
To the equation, and you're just solving for a.
Yeah. This is 5 minus 10. Honestly, I would use my other calculator for something like this.
Yeah. No, just do it in your head, bro. It's easy.
In the multiplication here.
I think your bracket's just wrong for 5 minus 20 as well.
Oh yeah, the square should go on the outside.
Yeah.
Highlight all of that. Interactive. Solve a. And then you get your answer as a is equal to 1 over 10,000. So you can write your final equation as just y is equal to 1 over 10,000 x minus 10 cubed, x minus 20 squared, right? One more thing you could have done is you can write here, like the steps that you wrote in your calculator. It's really good practice. So you just write, you can just write substitute in anchor point. So you go sub 5 comma negative 225 on 16, and then solve for a. And then you get, there's not a space here, but you get a is equal to 1 over 10,000. And then therefore y is equal to, and then you can just write your final equation.
Yeah.
Do you have anything to add?
Yeah. One thing, a lot of people try to substitute in a point that's like part of the intercepts, part of our model.
Yeah.
So for example, like because we know the graph passes through the origin, right? They try to substitute in 0, 0 to find our a value. But you can't substitute in any point. You have to substitute in like an external point from what we use to model our original equation, like our skeleton equation.
Yeah.
So if we just think about the points that we use to model our equation, right? We used 0, 0, we used 10, 0, and we used 20, 0. Obviously, those were different styles of intercepts, but they'll all pass through our function. But we can't use any of these. First of all, like usually you can't substitute in intercepts because they're part of our model.
Yeah.
So that's why it provides us with the external point that's outside of them. It kind of gives you the stretch. Yeah. Because obviously, like you can't determine the stretch if it's lying on the line.
Yeah. So all these values that we substituted in, they're intercepts. So you can't use an intercept to find a dilation factor.
Yeah.
And if you realize, if you look at this anchor point here, it's 5 comma negative 225 on 16. It's non-zero. Yeah. It's a non-zero. Yeah, exactly. So it's a point which is somewhere over here, right? So that is the point that we're going to use to find our dilation factor. Question B is just sketch the roller coaster over the domain representing the distance of the roller coaster. So I've pretty much done it, but like it's over the wrong domain. So you have to start. You have to start at the origin. We continue going down. I'm just going to write over it again. We inflect. We form like a maximum turning point and we come down and we continue. Supposedly we continue upwards this way and this way, right? But we know that we start at the origin. So we pretty much can't have anything. I'm going to erase everything to the, my eraser is not working. Oh, there we go. We're going to erase everything before 0 and we're going to erase everything after the turning point because we don't want to have that, right? So pretty much we have a graph which looks something like this, where we start at 0 and then we end at 20, 0. If I can get my thing to work. No, it's not working. Gonna have to give me a second, guys. Stop share.
So this only happens during the masterclass. Like during normal sessions, like it's fine.
Yeah.
And then when you've got like 3 things running at the same time,
Yeah.
from multiple computers, that's when just everything just.
We like people in a Zoom, yeah.
Yeah.
The graph is missing. Okay. Cool. All right. So then this will form a local minimum, come back down, local maximum, come back down, form this minimum. It's going to stop here. It's going to start here. So your starting point is 0, 0. Your ending point is 20, 0. You know you have a point of inflection here at 10, 0. And you know your anchor point, well, they give it to you as 5, probably somewhere here. Oh yeah, okay, 5, negative 225 on 16.
Yeah. Okay, cool. Right, I got a couple of questions.
Yeah.
So like the general graph, is fine with all the points that they're given.
Yeah.
I guess, do we have to know that like the turning point is there and the turning point is like specifically there, like with the current knowledge that they have?
Oh, well, they haven't done differentiation yet. I mean, they did it last year.
Yeah, but like for this year, you probably wouldn't be expected to know it right now.
Yeah.
But once you learn differentiation, you'll be expected to find those like key points.
Yeah.
Although you can find them with the calculator.
Yeah.
You don't know differentiation like explicitly.
Yeah.
Like through 3-4 methods.
Yeah.
So although it's like assumed knowledge, for now, just don't worry about it. Because a lot of people.
Yeah. You need to find them, but we have more masterclasses for differentiation anyway. And when we do those, we're going to show you how to find them and how to use your calculator, more CAS tricks anyway.
Yeah, cool. And then also like, I guess like another thing to double check that we did this right was just double check your function or like double check your shape and just tick off all the things in the question that like guide us to how to graph it. I guess like the first key thing that I see is that the journey starts from origin and then it exits underground tunnel. Yeah. So like if we see that, we start at the origin and then we go downwards. Yeah. So like technically that's underground because the y value would be less than 0. Exactly. And then we go to a point of inflection at 10, 0. We can graphically see that that's correct. Yeah. And then we have it finishing. We're finishing at the other turning point. Yeah. So maybe if anything, that point should be a bit more like, it's hard to sketch from the calculator. Yes. But like that should be flat there and then end at the point where it's flat. Exactly. Yeah. Yeah. But then you have your, will we expect to level the point? Yeah, I think someone said in the chat, will we expect to level the points 5, negative 225, 16. I think you did. So. No, are they asking, are we expected to do it? Oh, yeah. Yes. Given to us? Yes. Yes. And also when you're sketching a function, if you do the intercepts and you don't have some sort of anchor point, imagine your teacher looks at that. Your teacher's not going to know whether it's this function or another function. So the answer is yes, you do need a point other than an intercept to just show that it is that specific graph. Yeah. Okay, so I'll give you an example. If we have y is equal to x squared versus y is equal to, so this is x squared. If we have 2x squared, it's going to look exactly the same and you won't be able to tell the difference. Yeah, you don't know like the scale. Yeah. The only difference is you have to substitute in a point 1, 1. You have to substitute in the point here, which is going to be 1, 2, right? And now you know, okay, this is y is equal to 2x squared. This is equal to y is equal to x squared. So that's the reason you do need an anchor point. Yeah, cool. Okay. All right, we'll give you some time to copy that down in case anyone missed. Well, thank you guys for going through these questions with us. I guess stick around to see how you guys can continue with us and how we can essentially help you succeed in VCE and get the results that you dream of. Go on, come in. So essentially, like what we'll go is essentially like go through a week in a life of like a mind learning student, because our course essentially, it's not just like one-off sessions and things like this.
Yeah.
It's like continuous help and support that we provide throughout like any time period that you have, whether you're just learning content, whether you're preparing for a SAC, preparing for an exam, anything like this.
Yeah.
So like a typical week in a life is, you know, Monday. So Monday, what we do is, well, not any Monday, but in general, when you start tutoring with us and start, you know, our course, so our program, we mail out a booklet of revision questions and SAC and exam type questions. So these are more unique from your textbook and are more catered towards those SAC and exam type skills that the textbook and the teachers kind of lack teaching you in. And it's specifically designed to cover all the content most effectively. So these would be, you know, like a limited amount of questions, but like just enough to like get you the understanding and the knowledge that you need.
So if you guys like this seminar and you like the type of questions, like they're similar questions to that. And we actually took some of the questions from our booklets. So if you want access, so those booklets will give you access to these questions, which are easy and then hard. So there's like a range of questions.
Yeah. So typical Tuesday, ignore my weird face in the photo. But so let's say like one day throughout the week, we're going to have a Zoom group session. So it'd be like maybe like a 1 hour session where we go through a concept for that week.
Yeah.
So that'll be every week. You could join our group session
and just ask any questions.
We're just going to go through content.
Yeah.
And then we're just going to, go through the content. And like we try to stay ahead as possible with our content, because we want to give you the most amount of time to prepare for SACs.
Yeah.
So keep you well ahead of class. I'll give you like a quick story. Like last week, one of my students had COVID.
Yeah.
And then he was out of school for like a week and a half.
Yeah.
But like we were like pretty far ahead with like the content, the coursework.
Oh, it didn't
and then
matter.
like it didn't actually matter. He was still ahead once he came back to school.
Yeah.
So like that's why he was like really grateful that you know we had kept ahead. So like if anything like that unforeseeable happens, you're good. Like you're fine with us.
Yeah. So the seminars happen once a month, but then the Zoom sessions are like every single week. So pretty much you get, it's like you get to, it's very similar to the seminars, but we're going through content that you guys can ask us specifically if you have any like difficulties with anything.
The masterclass are more like showcase of like VCA walkthrough questions.
Yeah.
Or like we take questions from VCA exams and we specifically break down in like a SAC or an exam context.
Yeah.
A typical Wednesday, what you would go through is like, let's say video walkthroughs. So like those questions that we said we provide in the mail, we actually have video walkthroughs of those questions that are recorded, specifically by us. And, our teaching style, I would say, is like pretty solid.
Similar,
It's like you're pretty similar, pretty solid, like considering, VC, we tutored VC for a long time, teach at Monash, like we're very used to like online format. And we know specifically how to structure, like a content video and make it the most effective for you. Yeah. So we answer the questions and we teach you the concepts simultaneously. Yeah. And you get a really solid understanding of those exam style and SAC style skills. Yeah. And then, but like it's at your convenience. So you can do it literally anytime.
Yeah.
And
so every single question that you get in the booklet, there is a video walkthrough for that me or Adrian have made.
Yeah. Yeah. Way better than your teacher. So like last dot point says.
Yeah.
Trust me, it is.
Yeah.
Typical Thursday, you can message us for help. So you're able to ask questions outside of these classes and these like scheduled times. And this is like a really useful really useful feature that a lot of people have taken advantage of. So outside of of the group session or outside of the master classes, if people have specific questions, you feel free to like message us and we can help you in between those sessions. Yeah. So you're not just getting like the live stuff, you're getting everything outside of that. And we literally help you, pretty much any time of the day. We guarantee a reply within like the end of the next day, within 24 hours. So like, who doesn't want that? Like when your teacher's unavailable to reply to your emails, if you're not at school on holidays, things like that, we're able to give you help at any time. That's all included in the course. So that's a typical week. And then typical Saturday, maybe like a masterclass, which is similar to this. Yeah. But it would be most likely like once every 4 weeks. More frequent when it's closer to exams because we want to maximize the amount of study that you get. So it's very similar, except we go through VCA questions and we go through them more thoroughly. So there'll be one masterclass for each major topic, and then their SAC and exam specific seminars that are covering what your teachers don't. So a lot of the time, a lot of teachers don't cover the content.
Yeah.
And you need to know, like they cover like subsistent level, very basic surface level concepts and things like that. But I bet that like all the concepts that we went through today, or like most of them, your teachers wouldn't have taught you.
Especially the CAS skill stuff and dynamic graphing and all of those that like there's so many more little things that you need to know in order to save 5-10 minutes in your exam so that you can use that for like another question, which you might be struggling with.
Yeah.
And those are the small things which actually add up and boost your study score to above 40, or like if you're really struggling to get much higher.
Yeah, exactly. Yeah. Because imagine like we went through 3 questions today. You probably saw like maybe like 1 trick in each question.
Yeah.
Like imagine that over like a 10 or a 15 question like exam or SAC. Like imagine how many things like add up.
Yeah.
Like you might think, oh, it's 1 mark here or there.
Yeah.
Imagine that times like 15 or 20.
Yeah.
That'll like substantially drag your score down. But like what we want to do is bring it up.
Yeah.
And push you to that next level that like you probably wouldn't have thought you could have achieved.
Yeah. And starting this early is really good because you're getting exposed to this at the start of the year, which is the ultimate advantage to doing well at the end of the year.
Yeah.
If you guys just think about it, if you did VCE exams every single week, every single month until the end of your exam period, and then you started doing
like 45 plus.
Like
easy 45 plus.
It's very guaranteed that you guys are going to do well.
But like obviously you guys really care, and you guys are obviously here like very early in the year, which is like honestly like really impressive. Like you guys are obviously very driven to like get to that next level.
Yeah.
So we really appreciate you guys, coming around, and because of that, want to give a special offer to you guys as a thank you for coming. Yeah. Thank you for staying around. So But before that, we'll just introduce Tara really quick, because Tara is like one of our previous students and can talk about how I guess her experience with us at Mind Learning. Yeah. It'll just be pretty brief, but thank you, Tara, for coming.
I don't know. Do you want to stop your sharing?
No, they can still see your face. It's fine.
Okay.
Hello.
Tara, can you hear us?
Yeah.
Oh yeah. Try again.
Hello.
Hey Tara. Yeah. How are you today?
I'm good. How are you guys?
Good. Thank you. Thank you for coming along. We just wanted to like ask you a few questions just so like, the audience can get a bit of a feel about how you found working with us throughout last year. Yeah. So I guess like, it's honestly like, how did you find us like compared to, your regular teacher? Like we'll be able to like push you to that next level?
Yeah, definitely. I went into methods worried because I wasn't the smartest math student out of everyone. And I know that VCE is a competition, and as good as my teacher was at starting my learning, you guys really helped me push and solidify my understanding and make sure to give me multiple questions on topics that I really didn't understand until it became almost second nature, and always kept me accountable for my learning by messaging me about how my studying was going, as well as replying to my messages really quick on questions I had, which I didn't have available from my school teacher.
Yeah, no, that's really good to hear. We're glad we were able to help. I guess if there's one thing that stood out the most, maybe compared to other experiences you've had with learning, like what would be the one thing that really stood out for us?
Well, when you think of tutors, you think uni student who is strict with their method of teaching and pretty uptight, but you guys feel like just your mate. You're really easy to learn from, and I never felt like you were demeaning or above me or anything, which helped me learn more as well. But whenever I was doing a question that I needed help on the Zoom sessions, you'd always allow me to work it out with guidance, which made me feel a lot more confident and not like telling me the answer straight away. But if I couldn't work it out myself, you never judged me and always gave me multiple ways of how to work something out until it clicked, which got me to a great position at the end, which I believe was because of your kind of relaxed but more focused on me teaching style.
Awesome. Yeah, we're really glad to hear that. And you're like a pleasure to work with as well. I guess like, what would you say like there was the biggest improvement? Last question, like what do you think was the biggest improvement from like the start of the year to like after your exams, like looking back?
Definitely circular functions and integration were my worst topics. It never really problematic
sometimes. Yeah,
it never really clicked before you guys. a bit of background for everyone. I didn't find my own learning until probably start of term 3 on TikTok, which I'm sure a lot of other people found you guys here too.
Yeah.
And I saw that you had a free masterclass, so I joined. And these guys haven't told me to say anything. They told me to be honest. And honestly, I never hit pay so quickly. Just how good you guys were at teaching and going through all the questions. And it just got better with the Zoom sessions and also the online resources. And it was worth every single cent. And by the exam, I felt so confident in tan graphs and finding area, using integration, and all the tips and tricks you guys taught me. I literally went from just passing semester 1 to getting an A on both exams, which is beyond what I thought I could ever do in methods. So grateful.
Yeah, awesome. That's like awesome to hear as well. When we like found out about her scores, like we were ecstatic for her, like as if we received those results.
Yeah, exactly.
You know? Like that's like the amount of like passion and commitment we show to our students. So
honestly, the students going into the methods exam, you just like on the day, I feel like I'm doing the methods exam as well.
Yeah, like we feel that sort of anxiety. We're going through our own exams for uni, and then like we're just like, oh, like waiting for the messages. Oh, like, how they go in the exam? How they go in the exam? Like it's like one like big community. You know?
Exactly.
And like but the students definitely make it possible. So thank you to Tara for like speaking about that.
Yeah,
awesome.
Yeah, cool.
Yeah, I wish she was still doing methods so we can still teach.
But Tara's in uni now with us, so we see Tara very often.
I'm on Monash student now, guys. So
yeah, of course, yeah. We ate lunch a couple of times together. Like you're just like hanging out like mates. Like it's awesome. Yeah, cool. Thank you again, Tara. That was really nice.
Thank you, guys.
Yeah, no worries. So all of this, everything that we just talked about, just like the online course, the masterclasses, the Zoom consultations that we have every single week, and all this value is just $25 a week. So compared to like other tutoring, this is a huge ton of value, and we're only giving a lot of these add-ons. We're only giving to you guys, and this is only going to be on for like today and tomorrow, and then after that we're going to take this down. But it's just because you guys really seem like you want to do well at the end of the year. And I feel like getting started right now, going through these masterclasses, the Zoom consultations every single week. Imagine just doing VCAR questions every single week. We chose them specifically for you. There's no way by the end of the year, you're going to get a score that you're unhappy with. You're definitely going to get into the uni that you want. You're definitely going to get the score which you want. And you guys are just going to be happy overall with all your exam results.
Yeah. Exactly.
So as I said, again, this is like a special offer, like all these add-ons that you guys are getting. And this is only going to be for like the next couple of days anyway.
Yeah. So if you guys are interested, or if you guys have any more like questions or queries, like feel free to, message us like in the chat. Feel free to email us. We're more than happy to help out. But this is just like an exclusive offer for now. It's kind of more like a gratis thank you for coming today. So if you guys are interested, stick around, ask any questions. If you guys want to,
feel free to message us on any of the social medias as well.
Yeah, exactly. But I feel like it would be very, very beneficial to you guys. Obviously, you wanted to stay around for the end, so you guys are here for a reason. Kind of like this is kind of like a little taster for like what you would get if you did continue with us. So I would say like it's pretty good value considering you get your class, you get the seminars, you get the resources, all included in like the same thing. Like it's not like any like hidden payments or anything like that. It's like consistently, like the payment per week, and you get everything included, like what you get in, or like what you get out of it is like how much commitment you put into it. So you can get as much as you want out of it. Pretty much like you get like hundreds of dollars per week of value. Asking questions and stuff like that. I mean, I wish like something like this was available when I was a student. Like,
and when we were making this, we actually made it so that in a way that it has everything that I wish that I had access to, and Adrian wishes that he had access to when we were doing VCE, because that's the reason why we started this, started my learning, right? Because we didn't like the way that other tutors, other companies do things. We wanted to make this our way. This is our way. We have all this value. We have the masterclasses, VCA exams early throughout the year, so that you guys don't have to get anxiety when it comes to SAC times. You don't have to spend time up until 2 a.m. studying until when exams come near. Is because we push you towards that next level. We know what you guys need to be doing from week to week.
Exactly. Yeah. Oh, there's like one thing I want to add. Like, don't fall into the trap of like thinking, oh, the ATAR note seminars are good enough. Like, don't say, oh, don't go to school and say, okay, oh, they got ATAR notes, it's fine.
Yeah.
No, they're not. Like our masterclass is like shit on their masterclasses.
Yeah.
So, and we get all the other stuff with it, like the resources as well.
Yeah.
Don't worry about them. They're just like first year uni students and don't know anything.
Yeah.
Like, but,
Yeah. Yeah.
Like we know our shit. So
Yeah. Yeah.
But if you guys have any questions, like feel free to message us in the chat or like,
stick around.
Stick around. If anything else. But so this will like finish today. So like probably like today or tomorrow. Today. So guys want to like, you guys want any questions? Feel free to ask. Stick around
if you're interested, have any questions, feel free to DM. Feel free to ask now. Other than that, thanks everyone for coming. Follow the TikTok. Follow that social media. Yeah. No worries, guys. Let's see if you have any questions. How do we sign up? It's on our website. I'm going to link it here. Oh, Adrian, can you just type the website in the chat? MayanLearning.com. If you type in Mayan Learning on Google.
Yeah. And it has like a link to like the plans. And this is included in like one of the plans.
Yeah. So if you go to plans, you can sign up.
Do you offer chemistry classes?
Yes, we do. We have a group class.
Yeah. So like, for chemistry, like we don't have any like slots for like private classes right now, but we do offer like group classes. So if you and a couple of friends want to join like one of our group classes, like we could like create a private one just for you guys. Like we specify it to like your
school, your SACs, because it'll be just
because every school has like different ones. So we don't offer like a general one for chemistry because all the orders are different for chemistry.
Yeah.
But like if you have a couple of friends from your school that like you want to join with and do like a discount group rate, then like we do that as well. Yeah.
Apart from that,
anyone have any questions? Or like any honest feedback? Like if you guys are still sticking around, if you have any more questions, like because like we cater it for the students, right? So like if you guys have any like things that you guys want to see, like in the course,
next seminar,
or just like in the course as well. Like if you guys want to see anything like extra, like what do you have? Physics course, like it's the same thing with that. It's like it's probably like a private group class because like every school does physics in a different order. So like we can't do just like a general one.
Exactly. But usually like there are a few physics classes right now. So if you want to make a physics class, we actually go through VCA exam questions. That's literally all I do in my physics classes. I just come up with like 10 different VCA exam questions for like circular functions, and I just do all of them back to back. And the students really like it, and they feel like their learning gets really consolidated in those sessions. So yes, because me and Adrian, we did physics, chemistry, methods, and spec in high school. We did the Asian 5 pretty much. So we're really good at those subjects. Plus, we needed to learn so much physics and spec and methods and chemistry when we're doing engineering. That's pretty much what it is. That's the whole of engineering. So we're very versed on that.
Anyone have any feedback?
No one replied. No. If anyone has any feedback, feel free to unmute yourself. Put it in the chat.
Hi guys, this is Nirav here.
Hello, how are you?
I just want to know, like, where are you based actually?
Like our location?
Yep.
We're in Melbourne.
Yeah, we're in Melbourne. Like
we're close to Monash.
Yeah, we're close to Monash. We're in Monash right now, Monash University.
Yeah. When I say like where are you based, it means like which suburb of Melbourne. That is what I'm asking.
Okay, well, like everything's online. So like we're just like in the southeast area, but like everything that we have is like everything's virtual, everything's online.
Okay, so you don't do face-to-face class?
No, we don't do face-to-face. Yeah, it's going to be very similar to how we had it today.
Yeah,
that's okay. So you can see my phrase that I already got the white beard. I'm not a student actually. I'm a tutor.
Okay.
I also teach math methods and physics, but I'm based in the western suburb.
Right.
Okay. Yeah. Cool. How long have you been? Wait, do you do it like private or for a company?
No. Basically I'm an IT consultant, but I like to teach.
Oh, okay.
Right,
I have
right.
been tutoring methods for like last 5 years now.
Oh,
Yeah,
cool.
okay.
Yeah, awesome. Yeah.
Very similar.
And like I also have a couple of method students. I actually attended the seminar just for them because they have some work.
Yeah.
And they asked me that, can you please attend the seminar and let us know?
Yeah. How did you
That
find
is the
it?
reason I attended the seminar.
How did you find it?
No, it was useful. It was useful. And
Yeah.
one of the questions that I asked was like, how do you find out the inverse of cubic equations?
Yeah.
Right. And I expected the same answer from you also. But
Yeah.
that
Oh,
was
yeah, cool. Cool. Yeah. Would you give any like feedback to us?
No, I think it was good actually. Yeah.
Okay.
Some of the questions that we came across in last couple of years, many of those questions that you covered, they are very similar to exam style questions.
Yeah.
Yeah. And that's why, yeah. Like that's like our goal. It's like
majority of in my experience, what I would say is the students who really do good in math methods, they are really good with the content actually.
Yeah.
They know their year 11 really well.
Exactly.
And sometimes if they are not good in their like content of year 11, and when they start with year 12, and when you try to explain all these difficult concepts,
They don't understand.
they struggle actually. They
I
find
say that to all my students. I say
except for like there's loose ends you have to fix up before you start. You can't just like jump straight into 3-4 without like fixing those gaps.
Yeah. I say like the secret to year 12 is year 11. That's what I say to a lot of students because it's very similar. Like it's the foundation is a lot for methods is year 11 and you're just putting things on top of that. And if you don't understand like the year 11 stuff, it gets very hard to teach because now you have to go back and teach the year 11 stuff and then you're behind on year 12.
That is true. That is true.
Yeah.
That is what I also experienced it. So it means like whoever is doing year 11 method, I just make sure that like you understand the year 11 correctly.
Yeah.
Then year 12 will be a little bit easier.
Exactly.
Otherwise, like you will always struggle in year 12.
Yeah. Yeah.
No, I think it was really good for me also. It means nothing new I have learned, but like I understood that like what are the different ways to do the different things. It is something that I already knew, but of course there are always different ways to do the things.
To learn exactly. Yeah. And like our teaching styles are always different. Like Adrian teaches slightly different to me. You might teach different to us. Like it's different how we teach. But the concepts are the same. So there's just different ways of explaining and doing the same things.
They are the same concepts. That's true.
Yeah.
No, I think it was, I'm very happy that I'm part of this seminar. In fact, like, as I said, I wasn't part of it, but one of my students suggested that you should go and attend and let us know because they were very busy with some work. But
how did they hear about it?
I don't know, maybe some Facebook group or something.
Okay. Yeah, maybe. Yeah. That's interesting. Well, obviously like we appreciate the feedback as well. So thank you very much. Thank you very much for attending. If you have anything like this, feel free to invite us. We're more than happy to come along.
We'll join your one.
Yeah. In fact, I refer a lot of other materials, not only like the specifically Australian books. I also refer a lot of US books and try to create a very similar kind of questions.
Okay. Do you notice it like
it's not only about so for example, like we know that like the methods is like we have the Victorian curriculum, but sometimes you can also refer the NSW curriculum and try to create the questions like that.
Yeah.
And so I believe that it is all about the concept. 1 mark here and there, it is not a problem. But if you understand the concepts, you can answer any other question.
Yeah. And that's the benefit of doing it online as well. Like we have that reach to the rest of Australia. And like, we can teach anywhere across Australia because the course is very similar. So there's no issue with that.
Yeah, some of the students are in Queensland, which I'm teaching.
Yeah,
and the course is very similar because
it's exactly the same.
There's no difference at all. Yeah.
Wait, so you said you teach on West Side, like so you're in person, I assume?
Yeah, we do face to face only. I never do. It means like preferred way is face to face because I don't like doing online all the time.
Yeah.
Online because sometimes students, I don't know what student is writing, where are their mistakes.
If they're on their phone, you don't know.
Yeah, exactly. Yeah.
If they're on their phone, they don't know. So it means
exactly. Yeah.
But
I like to be with the students. I like to connect with the students.
Yeah, that's fair. Yeah. Well, before we continue our chat, did anyone else have any questions? Arbi or Adra? Did you guys have questions? No, they're just chilling.
I know Adra.
Yeah.
Adra's IB student.
Oh,
yeah. Adra's the IB student.
Yeah. Of course. Yeah. Those names sound familiar.
Yeah,
Hi.
Hey.
Hey, nice to meet you. How about Abby? Did you have any questions?
No, I didn't really have any questions on content, but
Yeah.
I did ask about one-to-one tutoring because in the group classes I wouldn't learn as much. I think I learn a lot better in one-to-one tutoring. So yeah, ask if there was any slots available.
Probably not for one-on-one. Like we're pretty full.
Yeah, we had a lot of interest, and we're pretty booked out for like one-on-one tutoring.
Yeah, so like literally our schedules are both respectively like full.
Yeah,
because we had like a lot of demand at the start of the year. But like I guess like the small group, like we do host like small group classes. So like if you like a couple, as I was saying before with the chemistry one, right? You could like come in with your own small private group, and then you can like pretty much make your small groups yourself. It's more like private. It's more like, let's say if you have a couple of mates like on a similar skill level. Yeah. Like you could get the same course as before, but instead of like the big group with all of the students, like as a big student pool, it would just be you and like, let's say 2 or 3 mates. Yeah. But like on a similar skill level, we could target exactly what you're doing in your class. Yeah. Is that something that you would be interested in?
I'd be open to like.
Yeah. Okay.
Yeah. So like, just like, if you want to like, maybe if you want to arrange like a small, like, a one-off session, just like try it out and see if that's your thing.
One-offs, yeah.
Yeah, like you could just like message us on Instagram or TikTok or something. Yeah. And like I'll just note down like Abby wants a free trial session, and then we can just arrange one with your friends and then see if you guys like it. If you do, then you can continue. If not, then obviously there's the other option of like the main group class. Or,
exactly.
Yeah, but private is probably pretty full for now unless like someone else drops out.
Yeah. So how many do you have? Like a few friends that are doing methods with you?
Yeah, I have right now. I am actually, I think I've been on a call with Hessen before, and in my situation, I'm basically getting tutored with like one of my other mates. I'm getting tutored via Zoom as well. And they basically go through like they're just going through the content of 3-4 methods basically. But I feel I do want to do like more exam questions and stuff like that. So I find this type of learning better, I guess.
Yeah, I guess. And like we'll cater, like we're not just going to like force our own like schedule onto you. We do it at your pace. So whether you want to go through transformations, functional relations, you want to go all the way to like probability at the end of the year. Like we could do whatever you want. Like we just follow what you guide. We don't just conform to like whatever the average person does. So if you have like, obviously you and your friends are going to have like certain topics that like you guys struggle with more and you guys are more comfortable with. So we'll just like focus on the ones that like you guys going to focus on.
Yeah. Okay. That's great. I'll message one of you on Instagram or TikTok or something.
Yeah. Just like, you could just like DM like the Mind Learning page and we'll just like reply to you directly through that. That's more than fine.
Yeah. Okay. Thank you for the lesson.
No, all good, man. Thanks for coming. Yeah. Audra, how'd you find it?
It was pretty good. I enjoyed it.
That's good.
That's good. Yeah. We have like the one next week with like the Beaker questions. So the Beaker questions, like the actual exam ones they ask, but obviously a bit different for IB. Yeah. But it'll be like the same shit pretty much.
Yeah.
Yeah. Because I was thinking of getting like a couple of classes before like big tests.
Yeah.
So since you guys just said that like the one-on-one you guys are kind of booked out, so would I have to be joining in a group?
Since you're doing IBM, we already talked about it with you, right? So if you just want a few sessions just before like tests, that's fine. We can try and figure out our schedule, and that's only because we had a free session with you already, and we've been through everything. So so definitely if you want to have like a one-on-one session, just let me know. Like that's fine.
Also more than happy to do like let's say like a group class like with your friends, and then like if you actually want to do like a group class, right? You do the group class with your friends, and then like closer to test, you do like one-on-ones as well as the group classes, like because like, you know, obviously towards the test, you want to have like more frequent sessions to make sure you can consolidate your knowledge. So like that's actually an arrangement as well. Yeah. Like you have the group and then you also have like the one-on-ones just like as one-offs.
Yeah, exactly. Yeah. So if you want to have a group class with your friends, let us know as well. But if you want to have the one-on-ones, that's also fine.
Yep. Okay.
Yeah. Yeah, well, that's only because it's you and we've had sessions before.
Yeah, it's not like you.
Oh, I feel so special.
Yeah.
You are special.
Yeah.
Well, yeah, that's really it.
Yeah, cool. How's everything going though? Like, are you finding it all right?
Yeah, it was all right. I had my first test last week. Still haven't got my like the results yet, but it was
Okay.
pretty good.
What was it on?
Geometric sequences.
Okay.
Yeah.
Was that easy or hard, or how do you feel?
It was pretty good. I didn't think it was too hard. It was just because like a section of it, it's heavily using your calculator. And yeah, there's this one like n solver thingy, and there's just so many things, and it's so easy to get confused.
Yeah.
So, yeah, that's the only part I'm like a little about, but the rest I'm okay with.
Yeah.
Yeah.
Cool. Yeah, I guess just let me know whenever you want to have a session, or whenever, if you want to have like a group class. I don't know how your friends are finding it, like a group class with your friends, we go over anything.
They'd probably be interested, but yeah,
Yeah.
could ask them.
Stuff like that. It's probably like more efficient that way anyway. So
Yeah.
Yeah.
Yeah. So thank you for today.
No worries.
Yeah,
We'll probably
no.
like see you next week in the actual one, in the private one, if you continue. Yeah.
Mm,
Cool. Anyway, enjoy your weekend. Nice to meet you again.
me too. Yeah.
Nice.
Bye.
Yeah.
Hey guys.
Hey.
Yeah. Hi. Sorry, I just have two questions.